Okay, continuing with example 4. This time around we go the other way. I give you the Cartesian equation of the line. I ask you give me back the vector equation of the line. So what to do is, this is what you have. Okay, you must understand that all your three values, x minus 1 over 2 equals to y plus 1 over 3 equals to z minus 2 over minus 2, you're going to let it equals to 1 and not alpha because they're all supposed to be the same. And this time around, what you do is, you do the opposite. You try to make x, y, and z the subject of the equation. So you have x equals to 1 plus 2 alpha, y equals to minus 1 plus 3 alpha, z equals to 2 minus 2 alpha. And I'm putting them into the equation of the line. It looks like this. Okay, x is actually 1 plus 2 alpha. Y is minus 1 plus 3 alpha. Z is 2 minus 2 alpha. And when you write it in this form, this will actually give you the vector equation of the line. Okay, so this is how you actually do it if you want to do a lot of working. However, if you actually can remember the form, okay, this is your so-called Cartesian equation of a line. All you need to remember it comes from x minus something over something. So all you need to do now is to actually fill in the blank. Okay, all you have to do is fill in the blank. Focus on this number, this number, this number. The form is x minus something over something. So I already have x minus 1 over 2. So this must be 1, this must be 2. The form will be y minus something over something. So this will be minus 1, this will be 3. This other component will be 2 and minus 2. So you can actually write down the vector equation of the line just by staring at it and just remembering the standard procedure. Okay, so this is the way by which you actually find the vector equation of a line very quickly. So what about the next part, B? If I were to give you things like this, x equals to 2z minus 4, y equals to 3. So this kind of question looks a little bit more intimidating, but the rules remains the same. Understand that y is always equals to 3 and x is equals to 2z minus 4. So let x equals to 2z minus 4 equals to 3. This is your standard procedure. And then if x is equals to alpha, z will be 2 plus half alpha. And don't forget, y is always equals to 3. So this is how you actually write down the equation. X is equals to alpha here. Y is equals to 3. Z is equals to 2 plus half alpha. Thereafter, split into your separate component. Keep the numerals on one side. Keep the alpha component on one side. You actually have the vector equation of a line very quickly. Okay, so next we're going to move on to section 4.2.3, which is the vector equation of the x and y and z axis. We actually come across something like that before when we actually deal with the directional cosine. I asked you guys before, what is the direction of the x-axis, and most of you can tell me it's 1, 0, 0. So all you have to do is recall this same concept. Okay, so this is basically a rehash of what we've just gone through in the earlier chapters.